Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me for another video. Make sure that you go check out my other playlists on topics like PowerShell and LXD and Windmill, which is an open source low code application, and a bunch of other great videos on my channel. And make sure that you subscribe to this channel so you get notified about new videos. And if you learn something by the end of this particular video, please leave a like and a comment with what you learned. So what we're going to be talking about in this particular video, just to set some expectations, is an introduction to how to get started with the Rust programming language. So Rust is available over at rust-lang.org. So feel free to head over there in your web browser to see the documentation and all that. But we're actually going to be installing Rust onto an Ubuntu Linux server, a headless server, and this will allow us to develop applications on a remote Linux environment. I'm actually running Windows 11 on my client-side system here, but I can use my Linux server as a virtual machine to basically just install Rust and compile my Rust applications and test them out. So we're going to be exploring how to basically spin up a virtual machine from scratch in Linux using LXD, which is why I encourage you to go check out my LXD playlist, and then get Rust installed, validate the environment, write a really simple program on that server as well, and then you should be able to get started with some other Rust concepts after this. So let's talk a little bit about Rust in general. So Rust has been around since about 2006. It actually started at Mozilla, who's also responsible for some very popular open source projects like Firefox and Thunderbird and a bunch of other ones. So it came out of Mozilla in about 2006, but it didn't really gain much popularity until the mid-2010s, around 2015, when the version 1.0 was originally released. Now, the Rust Foundation actually got spun up when some layoffs occurred at Mozilla. You can read all about that on the Wikipedia article here, but the Rust Foundation was created, and that's really the backing entity behind the Rust programming language. Now, there's 5 companies that are really backing this primarily. It's AWS and Huawei, Google, Microsoft, and Mozilla as well. So there is quite a bit of backing, financial backing, and support for the Rust project. And it's a really great language because it's actually pretty high performance. It's very close to C and C++ levels of performance, but you actually get a lot of benefits over C and C++ developers with Rust because it's an easier language to write code inside of. You still get the performance of C and C++, but the compiler is really where a lot of the magic happens. It helps you to write robust applications and handles a lot of the memory management for you so that you can focus more of your time on writing business logic rather than having to spend a lot of time dealing with memory management. So Rust is a really great kind of middle ground for anybody who needs something that's higher performance than maybe Python or PowerShell or Java, but they also don't want to necessarily drop all the way down to something like C or C++. Something that's also comparable to Rust would be Golang. So if you're interested in learning a high performance language in the modern day and age, then either Rust or Golang would be excellent languages to learn about. So we're going to go ahead and get Rust installed. And to do that, you can head over to the rustup site. So rustup is the utility that we use to actually install Rust. And so if you go to rustup.rs, that's the website where the Rust installer is available. It does run on macOS, Linux, as well as the Windows platform. But if you're installing Rust directly on Windows, you actually have to install the Microsoft build tools for Visual C and C++. So keep that in mind as well. That is a really large package, so it is a little bit onerous to install Rust on Windows, which is why I generally encourage people to install and develop Rust applications on Linux. Linux is lighter weight. Rust installs pretty quickly on there. You can also run Linux containers with Docker and actually run the Rust compiler and development utilities inside of a Docker container. So that's a really nice way to build up a dev environment as well. So what you'll want to do is just copy this command here. Most Unix systems are going to have curl pre-installed on them. And if it doesn't, you can typically install curl with your package manager. But I'm going to be spinning up Ubuntu Linux Server as an LXD virtual machine on one of my bare metal Linux servers. And then we're going to use this command here to install the Rust toolchain. Now, the Rust toolchain involves a bunch of different components. And if you just click on this little link right down here at the bottom, it says About Rust Up. That'll take you to the documentation for Rust Up, which is called the Rust Up book here. And you're going to see a lot of different websites in the Rust programming language that follow this website format right here. And that's because they're actually generated with a utility called mdbook. So mdbook is an open source Rust project that actually generates these kind of online books from static markdown files. So it's basically just a static website. It doesn't have any kind of dynamic functionality that you can interact with. So if we do a search here, that's all kind of running client side. It's not really calling out to any APIs to the best of my knowledge. But a lot of the different Rust documentation things, including Rust Up docs, the Rust programming reference, the Rust book itself, which is kind of the introduction to Rust, are all going to use this common format here. There's a bunch of other books that you'll probably come across, like Rust Forge, the Rust programming language. This is the kind of core documentation for the Rust language itself. You also see the Rust reference here, and then asynchronous programming in Rust. There are also a bunch of other books that are going to be in this format, but once you see this kind of website format, it'll seem very familiar as you're working with Rust projects. So what we're going to do is take a look at the components here, and these components that we expect to be installed with Rust Up are going to include things like the rustc compiler. So this is really the heart and soul of Rust that allows us to compile source code files for Rust into a binary executable that the operating system can natively execute. We also have Cargo. Cargo is a really essential utility that allows you to install external dependencies into your project. So if you need to do something like building a web server using a framework, or maybe installing an SSH client or an SSH server, or installing any kind of third-party components, that's going to be done with the Cargo utility here. Then we also have Rust Format, or rustfmt, and this is going to help format your code automatically so that you can follow standardized style guides and make sure that all of your Rust code is indented and looks consistent across your entire project. Also, there's the Rust standard library, so that's just the core functionality that's built directly into Rust itself, without having to install any additional external crates. So the Rust standard library gets installed. There's a local copy of the Rust documentation here as well, called Rust docs. There's Clippy. Clippy is another important utility because this checks for common mistakes in your application. It checks for stylistic related things and common mistakes that just help to ensure that you're writing robust applications and that you're optimized for memory and other types of things in your code as well. So Clippy is a really important utility as well. But basically this tool chain is what allows us to get set up with Rust and compile applications and run them on our server here. So what we're going to do is switch over to my Linux server here. This server called Pangea is actually a bare metal Linux host, and I have LXD installed, which is going to allow me to create virtual machines. So the first thing that I'm going to do is use the LXC command line utility to talk to the LXD engine locally, and we're going to use the launch command here to create a server from the images. Actually, we're going to use the Ubuntu Lunar image right here, and then I'm going to specify a name for my server. I'm just going to call it Rust here, and then that's going to create a new container. So what I want to do is say --VM right over here, and that'll allow us to create a virtual machine instead. So once our virtual machine is created here, we can go ahead and get an interactive shell on it by using the lxc exec command. So we'll say lxc exec on the Rust server. Then I want to get a bash interactive shell on that server. Great, so now I've got a shell as the root user on my brand new Rust server here. And what we're gonna do is just paste in the command to install Rust Up, or install Rust using the Rust Up installer here. So this is going to be a really quick command right here, and then it's going to take us to the Rust Up installer, which is a little bit interactive here. So at the bottom, you can see we have three options. We can cancel installation. Obviously, we don't want that. We can use the default installation, or we can use the number 2 to customize the installation. For most use cases, you can go ahead and just hit number 1 here, but I wanted to talk through some of the concepts in the Rust installer that we can customize as well. So if we choose number 2 here to customize the installation, the first thing that we'll be prompted for is called the triple for the installation. And what this triple essentially consists of is the platform architecture. So is it 32-bit or 64-bit system? You can also install a 32-bit toolchain onto a 64-bit system, but you can't use a 64-bit toolchain on a 32-bit system. So if you do need to compile an application for a 32-bit system, you can specify that right here. Also, we have the target operating system right here. So in this case, we're installing for Linux. And then we also have the third component here. So let's just do a search for triple right here and then go down to concepts, toolchains, and then toolchain specification. And it tells us right here exactly what these different components are. So right here, this triple is actually going to include what's called the channel. So in just a moment, we're going to be able to choose which channel we want to install from. And so right now it's just set to unknown. But if we just hit enter to use the default triple, we'll be taken to the channel here. So by default, the channel is going to be stable. So that's the current stable release of Rust. There's a new stable version every 6 weeks approximately. And so if we check out the documentation for concepts channels for Rust Up here in the Rust Up book, you'll see that every 6 weeks stable releases are created. Occasionally they'll come out with maybe a patch release in that interim period, but the standard release schedule is 6 weeks. There's also a beta channel here, so if you want to take advantage of some new features that are going to be available in stable, but you want to take advantage of those features early before it's been actually released, you can specify that beta channel instead. And if you want to take a lot of risks with potentially a lot of broken code, you can also go with the nightly channel as an alternative. But generally, you're going to want to stick with either stable or beta if you want to be on the cutting edge, perhaps. So the channel here, we're just going to choose stable. And then we have the opportunity to specify which set of tools we want. So we have the ability to specify minimal, default, or complete. Now, normally you just choose default here, but you can also specify a minimal installation. So if we take a look at the tool chains over here, we can see actually which profiles we have available. So let's go to profiles under concepts, and you can see the minimal profile is going to include the Rust compiler, the Rust standard library, as well as cargo, but it's not going to include other utilities like rustfmt and clippy that help you to style your code and catch common errors. So most of the time, Rust developers are going to need at least the default profile. You can avoid the minimal profile in general, unless you're trying to build kind of a lightweight image or something like a Docker image or an operating system image. You can get away perhaps with minimal, but for your actual dev environment, you'll want either default or even the complete, which is right down here. All right, so let's go ahead and just choose default here. Now we have an option to modify the path environment variable. And what this will do is allow the operating system, in this case Linux, to locate the tools like rustc and cargo and the rustfmt utility and things like that. So generally we're just going to want to hit enter to say, yes, I do want you to modify the path variable. And then that's the last question. So we'll just say 1, go ahead and proceed with the installation. So the Rust Up installer is going to download cargo. Again, that's our package manager that allows us to download crates from the crates.io website right here. So if you need to install any additional dependencies, maybe we want to do something with SSH, so we can search for SSH-related libraries. Maybe we need to do something with network IO, so we can just search for network over here and find a bunch of different crates related to networking. And you can really just search through crates.io to find any crates that you want, or you can actually publish your own crates to crates.io. So crates is basically the alternative to, if you're a JavaScript developer, it's like NPM, the package registry where you can install additional packages from. If you're coming from something like C#, you would be using typically NuGet at nuget.org to install additional packages. So crates.io is basically the equivalent of those package registries. Same thing for Python. If you're coming from Python, you'd use Python pip package manager from pypi.org to install additional packages. So that would be the equivalent in Python to crates. Now, once all of these utilities have been downloaded and installed, it'll go ahead and say, all right, we've configured your environment here, but our environment is not yet aware of these utilities because we haven't set our local environment variables. So if I try to run rustc right here, you're going to see that it actually fails, but I could go directly into my home folder under cargo and go to env right here. And then I think if we do an ls right here, this should be where everything is located. Actually, it looks like that's a little different. So what I'm going to do is just exit my shell and then re-enter my shell. And because rustup already set my environment variables in my bash profile script, I can now run rustc just fine. So just exit your shell, come back into your shell, and rustc and other utilities like cargo should be executable in your shell. So now we've got Rust installed, but what if I want to write a Rust program? What's the next step? Well, I could use something like Vim to write an application, but generally I like to use a graphical utility like Microsoft Visual Studio Code to manage my code, just because it gives me things like multiple tabs. I'm very proficient with VS Code as well. It's got a lot of great keyboard shortcuts. It's got a lot of extensions that you can install, which are kind of like plugins that you can use to customize the VS Code environment. It provides auto completion and a whole bunch of features, right? So what I'm going to do for now is just write a really simple application using Vim, but then we're going to install the VS Code utilities so that we can improve our workflow. So let's just create a directory here called app, and I'll cd into that app directory. And now I'm going to do vim main.rs. You can call this file whatever you want to, but this is the file that we're going to pass to the Rust compiler, rustc, in order to turn our source code into a binary executable application, right? So what we're going to do is just start by going into insert mode. So I'll hit I on my keyboard, and then we're going to use the fn keyword here. And this is how we create functions in Rust. So we use fn, and then we specify the function name, and your application is going to always need a main function as its entry point. We're going to accept no input arguments, so we'll just do open and close parentheses, and then we're going to use curly braces to denote the body of the function so that any code inside of those curly braces is what's going to execute for our Rust program here. Now, if we take a look at the documentation for Rust itself, so we want to find the Rust programming language right here. There is a hello world example right here, and what you're going to see in a lot of Rust examples is this reference to println exclamation point. Now, this might look a little bit cryptic to you, especially if you are a new developer or if you're coming from a different programming language, but println is a common concept in the Rust programming language called a macro, and println allows us to just print some text followed by a new line character. So after the text is printed out, it'll just insert a new line character, and then our prompt will be displayed right after that. So we're just going to call out to that println macro right here and say, hello from Rust, Trevor Sullivan. All right. So we can close our parentheses there, and we don't need a semicolon in this particular case because this is the last statement of our function right here. So I'm just going to do escape and then do :wq to save that file. So if we do an ls-lga right here, you can see we've got our main.rs file, but we can't execute that file directly. So we have to compile this file into our binary file so that we can execute it and test our code to make sure that it works properly. So this is where rustc comes into play. If we just run rustc by itself, you'll see that there's tons of parameters here, but really what you need to focus on is the input file. What is the source code file that we want to pass in to our Rust program? Well, that's of course going to be the main.rs file right here. So we'll just do rustc, and then we'll specify main.rs, which you can tab complete as long as you're in that directory. And then we're going to get an error right here, and it says no such file or directory. So let's see what's going on right here. So normally I am doing things from Visual Studio Code, which kind of does a lot of setup work for you. But in this particular case, we need to install a package called Build Essential on our system. So I'm going to use apt update here since I'm using Ubuntu Linux here. It uses the apt package manager. And then we're going to install a package called Build Essential, and that should include the linker for us. So let's do apt install build essential. --yes, and that should get GCC and all of the other development utilities installed, which are ultimately being called by the Rust compiler. So once this set of packages is installed on our dev system here, we can go ahead and try to recompile our program, and hopefully it'll work that time. So just give GCC a moment to install right here, and then we'll come right back. Now that we've got GCC and all its related utilities installed, let's go ahead and try to run rustc against main rs again. And it's saying that it can't find that file, of course, because I'm not in my app directory. So let's go back into app here, and we'll rerun rustc. And now you can see that our application compiles successfully. So now if I do ls-lga right here, you can see I've got this new file. And the reason that it's showing up as green right here is because you can see that the execute bit has been set on that file, and the operating system can now directly attempt to execute that file. Now you also notice that the file size is quite a bit larger here as well. Our source code file is only 64 bytes in size, but our executable is about 4 megabytes in size. So if we do /main, you can see that our text is printed out. So congratulations, if you've been following along, you've just written your first Rust program. But there's a lot more to know about Rust. And one of the things that I really like to do with Rust is to actually use Visual Studio Code. So let's talk about how we can connect Visual Studio Code to our Rust server here and do some remote development with a graphical environment and some additional tooling that'll help us to write more robust code. So if you install Visual Studio Code on your local development system here, it runs on Mac OS, it runs on Windows, runs on Linux. But if you go over to code.visualstudio.com, you can just download the package for your operating system here, or you can use your OS package manager like Homebrew on Mac or Scoop package manager on Windows, or the Snap package manager, I think, has it for Ubuntu Linux desktop environment. But you can also just download a package right here, either a Debian or an RPM if you're on Linux, and install VSCode. And then there's actually an extension for Rust called Rust Analyzer that's available at the extensions marketplace. So if we click on extensions here, you'll see we've got tons and tons of different useful extensions for VSCode. And if we just do a quick search for Rust right here, you'll see that the official Rust extension was actually deprecated, so it's just called Rust. But now there's one called Rust Analyzer, and this is the one that we want to install. This is the currently maintained version. As you can see, it's been installed over 2 million times, and it is very well reviewed with 5 stars and 206 reviews. So this extension is going to help us to write our Rust code. It's going to provide syntax highlighting, auto completion. It's going to do linting for us to kind of look at our code and check for any issues that we might have in the code, like unused variables, for example. And so this is a really nice extension for VS Code that makes it a pleasure to use. So what I'm going to do is just fire up my VS Code editor right here, and we're going to connect VS Code to our remote environment thanks to another extension. Let's go back to the extension marketplace and just do remote SSH here. And this is a really sweet extension because this allows us to connect our graphical VS Code environment to the remote Linux server that we set up. And that's going to allow us to work on our project locally, but we're actually saving the files and compiling and testing our program on that remote Linux server. So what we're going to do is just go ahead and establish a connection to our server. The first thing that I need to do is to make sure I expose my server to my local network, because if I do an LXC list on my Rust server right now, you can see that its IP address is not on my local network. So I've already got a profile called Mac VLAN set up here. So we're going to say LXC profile add Rust and Mac VLAN. And I've got a separate video that talks about networking in LXD, but basically what Mac VLAN does is it allows me to attach the virtual machine directly to my physical network. So now I can directly access that virtual machine on my network rather than having to jump through the router in LXD. So now we can just connect directly to this IP address here from Visual Studio Code in order to manage our server. But there's one more thing I need to do before we do that, which is to set up my SSH key. So I'm going to copy my SSH public key to that server so that I can authenticate using my private key from my local system. So I'm going to go ahead and just print out my public key right here and copy my public key to my clipboard. Then we're going to go into our server. So let's go back and get an interactive shell on our Rust virtual machine. And I'm going to go open up my .ssh folder, go to authorized keys. I'll do I for insert mode, and then just do Control V to paste in my public key right here. And so now I can actually SSH into that Rust server from my local Windows system using my private key. All right, so what we're going to do is come back over to VS Code. We're going to go to the extensions marketplace, make sure that the remote SSH extension has been installed, which I already have. And then we're just going to hit F1 to open up the command palette in VS Code. And we're going to search for connect current window to host. And that is a command that's provided by the remote SSH utility there, the extension. And then we're going to just plug in the root user at the IP address that I just copied, which is 10.0.0.176. We'll hit enter right there. And then we're going to say, okay, that's a Linux server. And it's going to confirm the SSH host key as well to make sure that we trust that system. And then what's happening is the VS Code server is being installed on that remote system. And then it's going to connect this graphical environment right here on my client to that remote VS Code server. Now, once you're connected to that remote VS Code server, we need to make sure that we install the Rust Analyzer extension. So right now, if we were to open up our app directory right here in VS Code, that'll just cause the window to reload right here. You can see that I've got this Rust icon right here, but if we start typing something like fn test func, right? I'm not getting any auto completion here. I'm not getting any suggestions. I'm not getting any linting for my code. If I declare a variable like let x I32 equal 5, you can see that I'm not getting any help from the editor here. It does show that I have a Rust file here with the little icon, but we want our auto completion. We want code linting to show that we are never referencing this x variable right here in this function. So what we're going to do is go back over to extensions, Control-Shift-X, and we are going to search for Rust Analyzer, or you can just search for Rust typically. And then we are going to install this extension into our remote dev environment. And that is going to allow us to do auto completion and get code linting and all that kind of stuff. All right, so now Rust Analyzer has been installed, and I'm just going to go ahead and do developer reload window here in my command palette and see if it loads up correctly. Now, oftentimes you will get an error right here saying that it failed to find any projects, and that's because typically Rust Analyzer expects you to be working on a crate rather than just a standalone source code file for Rust. You can develop Rust applications without using cargo just fine, but typically Rust Analyzer expects there to be a cargo file. So what I'll do is do Control tilde to come back to my terminal, and we'll just do cargo init in my app directory here. And that'll create our cargo.toml file, which just contains some really basic metadata about our application here. And then once we've got cargo.toml here, it looks like our path is main.rs. So yeah, that all looks good here. So let's go ahead and just try to reload the VS Code window again to see if Rust Analyzer will pick it up. And so now at the bottom here, you can see Rust Analyzer is loading just fine. We're not getting any errors this time. And so now we're going to see that we get a bunch of nice features. So here's all this linting happening. It's saying, okay, test func is never called. Also, our variable x is never referenced as well. So what we're going to do for starters is just call our test func from our main function. So now once we save our file, the linter reruns and it says, okay, test func is being called now, it's being referenced. So that warning went away. Also, you can see that we have x right here is not being referenced. So if I just do something like print line and then specify a couple of curly braces and then pass in x right here, now we are printing out x, we're referencing x, and so that additional warning is going to go away. So this is one of the reasons I love VS Code, because it shows you those warnings. I can really quickly go fix those issues in my code, and then we can build a much more robust program. Also in VS Code, you have this little problems tab right here. So if there are any problems with your code, like if I rename my function here, now it's not being referenced once again, and I can just jump to wherever that issue is being found, and then I can go fix it, save the file, the linter reruns, and now I've just resolved all of the problems in my source code. All right, so now let's go ahead and try to run this application. So in our terminal, we'll just say cargo run. And as you can see, our program runs just fine. We get hello from Rust, Trevor Sullivan, and we get the number 5 printed out from our test function right here. All right, so that's pretty much everything that I wanted to demonstrate in this video, getting started with Rust on an Ubuntu Linux server. Now, if I want to switch over to my Windows laptop or a MacBook Pro, I can just use VS Code to connect to my remote Linux server that's running on a virtual machine, and I can pick up exactly where I left off, and I've got that synchronization on that server, which is just really, really convenient for me. Anyways, thanks for watching this video. Make sure you subscribe to the channel because I'm going to be coming out with more Rust programming video tutorials. So please subscribe, leave a like on this video, and also leave a comment. Let me know what other types of topics you are interested in. We'll see you in the next video. Take care.